My name is Florijn de Graaf. Yeah, you presented it, you pronounced it correctly, Roman. And I'm an engineer specialized in renewable heat and power systems and building technology. And for the past 10 years, I've dedicated my life and my career to, basically bringing eco-villages into the 21st century. And I'm now calling from Portugal. You see the nice background behind me. It's the village of Lousa in central Portugal, and I'm involved here with an eco-village project as well that I won't be talking about today. But there's a lot of things happening here in Portugal. And the reason why I decided to go into this field is because of this neighborhood that you see in the back. It's a bit pixelated, but it's my father's eco village. And I helped to build it 10 years ago. And while building it, I realized that this idea of having like local self-sufficiency and sustainability in the communities that provide their own resources is actually a really good idea or a solution for all the challenges that we are facing in the coming decades. So here you see a slide that details some of the problems we are facing. I won't go into detail, but basically when it comes to food, water, and energy, we are going to run into limits in the coming decades. And my way of looking on, as an engineer, on how to solve it, I think is through more decentralization. Because over the past 150 years, we've built a very complex economy with ever more increasing centralization. But as we saw with, for instance, the corona pandemic, when there was only 1 or 2 factories on the world where face masks were produced, the moment a crisis hit, a centralized system has a lot of single points of failures that can destabilize the whole system. And the way to make it more resilient is through decentralization. And that's also why I've been focusing on this decentralization for some of the most essential needs for us as humans, which is housing, energy, food, and water. And here you see a system that I've conceptualized together with a former co-founder of mine while we were both studying in Iceland. And the system you see here is a concept on how to fully circularize the energy, food, and water flows on a neighborhood level. And we've actually done the calculations on this system, and we've built much of the subsystems of it. And we are pretty sure that it should be possible to, on a neighborhood level, be 100% self-sufficient in terms of power, 100% self-sufficient in terms of heating, 100% self-sufficient in terms of water production and recycling, and 50% self-sufficient in food. So you cannot solve all your food production needs locally. Like, for instance, wheat and chocolate is difficult, but when it comes to herbs, vegetables, and fruits, it's very much possible. And the system that we are envisioning, it actually uses a combination of like more high-tech solutions, like for instance batteries and electric vehicles, but also low-tech solutions like helified filters and biomailer, which I will talk more about in detail later. And in doing so, it's also a bit of a move away from more traditional eco-villages, which are more, I would say, hippie-like, like bottom-up, people coming together to build a community, which has a lot of issues, in my opinion, because when people build their own village, then they have to learn everything, how to build, how to organize themselves, how to plan and manage. So with Smarthoods, my company that does this, we are trying to really work together with project developers to help distribute the expertise in a bit more of a top-down level, but still also allowing space for the communities to come up with initiatives and ideas themselves from the bottom up, but basically leaving the matters that require technical expertise to the experts. Here you see some of the analysis that we do on these systems. So we calculate all the flows. Here you see the flows for power and heat. So left is production, right is consumption. And we calculate them on an hourly basis. And by doing so, we can identify how we can better circularize certain flows and also quantify like what is the next peak flow that can be expected. And in doing so, dimension the system accurately. And by dimensioning accurately, we can also help reduce cost for the project developers that want to implement these systems. Here you see several, say subsystems that we've helped to build over the past year. It's electric vehicle parking lots with charging poles that allow electric vehicles to also feed power back into the grid. In the middle, you see an aquaponic system, which is a greenhouse system connected to fish farm. And then the plants are floating in the water. The water is pumped from the fish farm to the plants. So the excrements of the fish, the poop and the pee of the fish are the nutrients for the plants to grow. And then the plant waste we give to the worms and the worms to the fish. And in doing so, you create a system that produces both vegetables, herbs, as well as fish in a completely circular way. And then the last system is an example of a vacuum toilet system that is like an airplane toilet, like uses suction to flush the toilet rather than water. And by having the toilets flush with suction and not water, you get organic matter in a very high concentration, which then allows you to produce biogas from it or extract the nitrates and the phosphates in order to produce fertilizer. So you use less water and you recycle the essential ingredients that are present in the sewage waste. So creating a much more circular system. Here you see some of the projects we have worked on over the past year. In this village on the top left, that's the one that was on the first slide that didn't show properly, unfortunately. But that's the village where my father lives. And that's where it all started for me. That's where I got inspired. And it's a neighborhood of 23 houses that are built completely using recycled, locally sourced or sustainable materials. So for instance, the back wall of these houses is made from car tires that are stacked on top of one another in order to create a wall. So it's a very low cost and circular way of using otherwise materials like car tires, which you cannot really waste or recycle. Then on the right you see the Keuvel, which is in Amsterdam, a former ship wharf with very polluted ground, which has been turned into a clean tech playground with many different little companies in these boats, which have been insulated and such. And the plants that have been planted there, they help to break down the organic compounds that are in the soil, because there was a lot of toxic waste in that area as a former ship wharf. Well, in the bottom left, you can see Elleville, which I helped to build the first house of in the last winter. Elleville is a scalable eco-village concept that aims to provide eco-villages for the masses. So the goal is to build 2 times as fast and 3 times as cheap as the rest of the sector. So no lack of ambition there. And once this is demonstrated, the idea is that it's like an IKEA package. It's the same design everywhere and can be easily deployed to various countries. And in doing so, really bring eco-villages to the masses. In the bottom right, you can see Schoonschip, which is it's a floating neighborhood of 23 houses, which is very smart. So they have a smart grid with a battery that acts as the brain of the system, stores power during the day to give off at night. I'm going a little bit fast now because I see I only have 5 minutes left. So if I skip some slides, maybe I can treat them later.
Florijn, you have 10 minutes.
Yeah?
You have 9 minutes left. 9 minutes.
9 minutes. Okay, so let's see. Well, the idea of Smarthoods you can see here is to basically combine the best of all these examples that I mentioned into a neighborhood vision of around 150 people with own food production, recycling of waste, etc. And the idea was also to have it be like in a sort of modern, simple but modern style with a lot of solar punk elements. This was all just dreaming. We haven't realized it yet. And also maybe important to mention is that with Smarthoods, we are not the developer of these neighborhoods. We just provide the engineering for the systems. So it's different architects we work with every time. Here you see traditional Dream Factory in Portugal, which is more of a sort of like hippie community with, yeah, I would say like more like tech hippies that are very much into blockchain and crypto, and they have a sort of voting and organizing system all on the blockchain. I lived here last fall, and I helped to build a helophyte filter. And a helophyte filter, here you can see the construction, but this is one of the low-tech technologies that I was talking about that uses plants. Here you can see the full, the left picture doesn't load for some reason, but on the right you can see how it looks like when it's working, and it uses plants to filter the wastewater from the kitchen, from the showers, from the toilets. It's got like multiple stages with different plants in each stage, and by the end, clean water comes out. It's not drinkable, but you can at least irrigate the land with it. And this way, you don't need a wastewater treatment facility anymore. So you can implement a natural system like this. It's very low tech, and it means you don't need a sewage connection. And it's also not toxic because the plants, they break down the sewage. So yeah, this is an example of technology that could possibly also be deployed in Ukraine. And for Eleville, which I was already talking about a little bit, I also built a low-tech system that is easily deployable everywhere. It's the biomiler that you can see here. So basically what this is, it's a giant ring filled with 70% wood chips, 10% horse manure, and 20% organic matter. And it's a composting heap. So inside goes around 100 cubic meters of compost material, which then over the course of 18 months decomposes. And in the composting process, heat is created. And this heat is enough to heat 5 houses over 2 winters. So that's a lot of heat. You can also shower with it. You can shower the whole summer with like 20 houses, no problem. And this costs around 6,000 euros to make. So it has a very good business case. You can build it everywhere where you have horse manure and wood chips, which is many places. And it's simple to make. I mean, for me, it was the first time building it, built it with no outside help. I mean, it takes a little technical expertise, but it's like medium difficulty, I would say. And it's a very elegant solution because by the end of the 2 years, you not only have provided heat, but you also have compost that you can use to grow food on your land. And then for the last slide, I think can probably answer then a few more questions or go more in detail into something that is interesting for you guys. Here you can see like what we do with Smarthoods initially, like when we get a client, then we help them design systems that integrate all the energy, food, water systems and use the waste streams of one system to connect as the input of another system, with the goal of retaining as much of these flows locally. And the idea is also that it almost becomes like a living organism. Like it's by creating so many systems in your project, each of these systems can have synergies with several other systems. So the more systems you put into place, the more it starts working together well, and the more sort of symphony starts emerging. And we can also say that this approach that we take with Smarthoods, I think it's getting more and more common, but I think like we really have like some unique knowledge that really allows this level of complexity to work together well. And I fully believe that this can really help to basically give power back to the people, because if you live in a community like this where you have a roof over your head, you have produce your own food, you have power coming from the plug, and you have water coming from the tap, then you are very independent, and therefore you gain some power back. You are no longer dependent on other companies to provide for you. You don't have to use electricity that is produced by big coal power plants. No, you can really do it yourself. And if you cooperatively own these systems, then I think it could be a really nice tool for the future to help transition us towards a circular society, towards a circular economy, and hopefully solve some of those challenges that I mentioned in the beginning.